Start class now, morning. Okay, again, update me on which chapter you're at in school for science. Electricity, magnet, 7. Magnet, finish already, not yet. You not yet. Electricity ni, parallel series circuit. Done, okay, done. So, now let's continue chapter 8, today's class. Again, what's the main title of this chapter? This chapter is all about that one word, the F word. What's the F word? Force. Okay, so what's the meaning of force? Force is a push or a pull, right? So this chapter is all about what can we do with a push or a pull. Yeah. Now, with a push and a pull, we can make simple machines. I'm sure you learned this in RBT. If you learn RBT. Any of you doing ASK here? Asal Science Computer? No, all of you RBT. So all of you would have seen the word tuas in Bahasa Melayu, right? So what can we do with force? Well, force can help you do help you do work like push, pull, and what can you do? Push, pull. So they come up with what we call a lever. All right, lever in your Malay is called tuas. If you learn in why I'm writing it, because it's the same thing you learn in RBT. Simple machines. Yeah. Now, what is the lever? The definition of lever is basically a bar that rotates on a fixed point. What does it mean by a bar that rotates on a fixed point? Imagine this pen over here. This is a bar. One bar, any bar it can be. Imagine there's a fixed point. I put a point that is fixed, that is non-moving. So when this bar, they can rotate. That means they can go around that point. We call this whole thing a lever. Or fixed point is here. Yeah, put bigger photos. Okay, or fixed point is here. The bar rotates around this fixed point. Basically, the whole thing is called a lever. Okay, so that's the definition of a lever. Purpose is help you to perform your task easily. Now, in every lever, you have three components. Valerie, what are the three components of a lever? Effort, load, and fulcrum. In your RBT, effort is what? Don't know. Effort is your daya in your RBT. Okay. Load is your starting with B. Isaac? Beban. And fulcrum is your fulcrum. KRUM. Okay, same thing. F you change the C to K we need for answer. Okay. So fulcrum, F, easy remember, is a fixed point. The point that does not move. It is here. For this machine, it is here. For this machine, the fixed point is here. See that? So effort is basically where you put your energy, where you put your force, where you push, where you pull. Correct? If I push here, my effort here, lor. I put up, then my effort here, lor. Understand not? Yeah. Load is what you want to lift up. Maybe I have a box over here that I want to lift up. Right? Then this is called my load. Understand? The object you want to do on. You want to carry the sand, you want to do whatever. Right? So there's three classes of lever. Tiga class tuas. Tuas class pertama, kedua, dan ketiga. First class lever, second class lever, and third class lever. Now, the difference between all of these three is our three friends FLE, where they are located only. Who is in the middle? So you look at the first class, who is in the middle? Fulcrum. Who's in it? For second class, who's in the middle? Load. Third class? Effort, right? Now, first class lever, fulcrum is in the middle. But look carefully, I did not put the word middle. In exam, cannot put middle. Middle means 中间, exactly. It not necessarily have to be here. It can be here. It can be here. It can be here, as long as it's between the load and effort. So how do I put in your exam? Anyone who puts middle, your teacher will probably mark wrong. You're supposed to say between load and effort. Understand? Okay, so for easy, I would say middle lah. But in exam, you just put between the other two only ma. There's only 3 of them ma. So fulcrum is in the middle. Second class. Okay, very easy to remember. Who is in the middle? Look at the keyword. First class, F. So, fulcrum in the middle. Middle. Second class. Okay. Second class. Okay, so first class, first fulcrum. Second class lever. What letter is this? Is this 2 finger?
No.
L shape, right? Second class lever, L shape. Load is in the middle. Easy, remember? Again, second class, your finger, L shape. So, load in the middle. Third class, 3. What letter? E. Easy, see that? Right? So, third class lever, how to draw finger? 1, 2, 3. 3 fingers, all right? So, 3 fingers, your effort is in the middle. Easy to remember. Can? Small little paper for your effort. It's in the middle. So, let's look at first class lever. You call lever, some of you call lever, I usually call it lever. Okay, first class lever, again, who's in the middle? Who's in between who and who? Who's in the middle? F. So, who's in the middle? Valerie? Fulcrum is in the middle, right? So, which part over here is the fulcrum? Again, fulcrum is a fixed point. Never move one the whole time. Which part? The center lor, 对吗? The center never move at all. Done. Fulcrum. Exam they ask you, oh, label where is the FLE? So where's the effort? Where do you put your strength? At the handle, right? Takkan you put your finger over here, you tap your finger. How to use? Alright, so you have to put your effort over here. This is the E. And then whatever object I want to do upon is the load. Okay? Easy. Scissors. I'm sure you know where again. Center here is the fulcrum, never move at all. Handle. Sini. Effort. And paper is my load. Can opener. Where is the fulcrum? So if you want to see clearly, can opener. Let me zoom in a little bit more. Okay, imagine this is the can, and then this is my cap. Milo tin cap. Milo tin cap. Let's just draw like that, simple. Simple one. Okay, let's say Milo tin cap. Cap on top. Can you imagine that? Yes, no? Can, right? The tin and then the cap cover on top. So where do you put your spoon when you open your Milo tin? Your spoon is like that. Correct or not? Wow, that's a really weird looking spoon. You can imagine. So the spoon over here, correct? Now look at this whole spoon. When you push down, where is your effort? Here is where you place your effort, correct? Now, where is the point that does not move the whole seesaw motion? Here. Is it here? No, you push down, this one can still go down. The point where it touches the T, correct? Right? You push down, that one will push upwards. You see, go down, this one go upwards. So this is my load. So that means my cap here is my load, my center is my fulcrum, and this is my effort. Okay, next up. Second class lever. Which point here does not move at all? Now, the action is not pushing the wheel. The action is just lifting up only. The action is a lifting up action, not pushing. Because if you push, then the whole thing moving. But now, I want it to be lifting up only. Which part does not move if you lift up? This one never move, man. From the floor, you lift the whole thing up. This point here will move up. Is the head. Wait, I say which part did not move, right? Which part did not move is the wheel, right? The whole time you lift up, the wheel will stay there, right? So this is the fulcrum. Your effort, where you put your strength, I hope you know, the handle, and the load is in the middle. You know, this is second class lever, L. Next, a nutcracker. You know what's a nutcracker? You put your nuts there and then you crush your nuts using a nutcracker. Okay, so where is the fulcrum? The point that did not move. Here, correct? And then the nut is the load, and where you put your force to push down. So L in the middle, L don't put again in the middle. Between fulcrum and effort, it is second class. Third class lever, if you can, find where's the fulcrum, load, and effort. Go. Okay, fulcrum is here. This is where you put your hand and cap, and then this is my load, correct? So E is in the middle, third class. Next, fish is always the load. The one is weighing me down. Next up, this is what? Effort or fulcrum? This is my effort or fulcrum, this point. Fulcrum. Because you need to lift the whole fishing rod up. You see, this point is like a fixed point over here, fulcrum, right? And where is the effort? Why is the effort here? Well, the effort is here because your force will be transferred to the body to lift up that fish. Some people even put the hand in front and pull up. So you see, you have the effort in the middle. It's not in the middle, but it's actually closer. That's why I say in between, right? Effort and fulcrum. Can? Now, I want to introduce to you another one. I want you to draw. Yeah.
Muscle.
Wow, big muscles.
What?
Okay, this action is the action of lifting up the apple like that. Like instead of bicep, you lift up apple. All right, so is this the first, second, or third class? First of all, you need to tell me, you need to label, right? So question I ask you, is this first, second, third? So you have to identify first. What is the, where is the FLE? Why don't you label where is the FLE? And then only you decide what class lever is this. Draw it at the bottom. Okay, draw ready and label. Where do you think FLE is? Start slow. The easiest is the L. Second, find your fixed point. Okay, so load is where? Lychee? Apple. Lychee, where's my fulcrum? Here. Here. Here never move. So my hand move like that to hold apple. Like that, my hand move like that. Which part never move? Elbow, my elbow never move. That's how I lift it up like that. You see that or not? So my elbow is the fulcrum. So where's my effort? Effort is transferred to here to lift up. You see, this is where the push is or pull is. So effort transferred to the center. So this up here is the effort, right? Yeah, so it's actually your muscles. Actually, effort is here. Your biceps pulling, your biceps pull, they transfer the force to the middle here to pull it up. Okay, the action is this like that. So it's actually this transfer to here because we're looking at this situation, the L shape only, the lifting up motion. Okay, so this is first, second, or third. Hello? The E mark. Okay, easy. Now, my next question is this. If this is a door, okay, let's say the door, this big. Okay, the door is this big. This is the handle. This one. Okay, so tell me roughly how do you think you're going to open the door with this handle? Like that, right? Push down, right? Like that. Okay, this one requires you to push down like that to open the door. Okay, now, question is this. If I push my hand here for a force of 10 Newton, and I push my force here, I give the same strength. That means I push here 10, I push here 10 also. Okay, I push here 10. A and B, where do you place your hand? Do you think you open the door easier? A or B? B. In between A and B. Okay. Okay, like here, here. I'm not asking you to touch. I'm not asking you to touch the corner. All right. You apply force here and you apply force over here. Which one is easier to do work? Okay. So of course you put in boy, right? As you can see, using your own pen, you can hold one corner of your pen. You just lightly push one. You push the same one. Try it out and feel for yourself. All right. Just push the same rough. Use the same strength. Don't push so hard. Push the same strength. Push the same strength. You know this is easier for that end there to fall down. Right? Why is that so? You are giving the same force. Shouldn't I be producing the same amount of work? So what do we say? Okay, when we push over here, not as easy as I do over here. So scientists cannot call this just a force. Scientists say, hey, because it's easier for me to do the work here, I say I have created a higher moment of force, and that is the title for this part today. Yeah, the overall force is moment. Like, why is it so? Because this moment of force takes in consideration one more extra thing, which is distance between the handle, the fulcrum, to your effort. You see? So the distance is shorter, my moment is lower. But the moment means overall force. Not only your force, but your force times together with distance push. But when I go further, I put the same force because my distance is further, my overall force, we call it moment of force, is much higher. You see that? Same thing goes to the broom. Okay, same thing like broom like that. How do you use the broom?
Down there.
Huh? How do you use your broom? Okay, is it easier to apply force over here? Force over here or force over here? A, B, C. Right? A, right? You just have to like push. Okay, if you hold higher a bit, the force is easier to sweep. You put down there, all the way down there, all right, harder, can sweep, but you're gonna put more. So, what's the concept? What's the concept? Okay, fulcrum over here. All right, the further is your effort, the easier. Actually, sorry, the broom, right? Further down is easier to sweep than put on top. All right, because the fulcrum should be further away from your effort, then it's easier to do work. Okay, so like in this case, putting your hand here, easier to do work than putting your hand over here. So what do we call it? We call it a moment of force. In other words, simple words to remember is the overall force that takes in consideration the distance as well. Yeah. So moment of force is a turning effect, basically your overall effect produced when a force is acting on an object. That's all. Moment of force depends on two things: how strong you press and the distance of your fulcrum to the force. Okay, 什么来的? Again, one more time. The door handle, fulcrum to your force. The distance. Okay, this is the distance of your fulcrum to force. So the further the distance, your overall moment of force is higher. So is there a formula? Yes, there's a formula. Moment of force is force times the distance of fulcrum to force, or in this case, effort. Now, why do you see I skip the word perpendicular? Exam, you should be writing the word perpendicular. Now, why call perpendicular? Let's look here. You know what's perpendicular? Mathematics. Hello? What's perpendicular? So, perpendicular to who? Perpendicular distance means what? Force is here. Distance is this one. Understand? Perpendicular distance, a 90-degree distance. Okay. So, moment of force allow your work to be done easily if it's higher. So, let's look over here since there's a formula already. Here. First one. Calculate the moment of force for A and B. Calculate moment of force for A and B using the formula. Again, I hope you guys don't just straight away put the number, okay, like that, okay. Don't put the number and then equals. When the question asks you for title, always write the title. Moment of force is... Why? Why do you think we must write title all the time? Guys, why must you write title all the time? Is it a... Let me ask you. Okay, a lot of students like to do like that, you know. Give calculation mathematics, right? Give you mathematics, and then here we'll do 13 times 3. And then over here, 1290 times 2. And then 1990 divide by 3. And then all your working over here. Imagine you go to the working world, your boss asks you, can you show me the calculation? You do like that. Okay, 12 times 2. You present to the boss. Nah. Your boss will be like, what standard 6 are you? All right, can be more mature and present all the answer in proper one line. I can see things. That is what we want to train girl. Understand? Don't be messy in your working world. Don't buat malu orang. Understand or not? Yeah, always present your facts nicely by putting a title. Yeah? Okay. So what's the force? 40 Newton, agree? What's the distance? 0.3 meter. This is also 40 Newton, but this is 0.15 meter. 0.1, 0.15. Calculator? Wow. Use brain to calculate. Take out calculator now. Calculate. Don't never bring y'all outside. You? Don't have. None of you are. Okay, lor. Then no answer, lor. Faster, one of you better sacrifice and then calculate. Handphone or whatever, take 12 ah. 12 what you need. N times M is what?
M.
N M. This one? Hello?
6.
6 ah?
6.
Sure?
Not sure.
I don't know. You tell me. 6? Agree?
6.
How you count 6 one?
Also don't know. Just tembak.
Handphone and calculator?
对吗？对吗？一定对的。Correct.
You think 6?
Yeah, I smart.
What? Okay, how do you manage to calculate 6? You really calculate or what?
Yeah, 6.
How?
Because I'm smart. People don't underestimate.
I know, but yeah, how do you manage to see the pattern at 6 without calculating?
0.
Oh, okay, you see like that. See, you can see what? Times 0.3 is 12. Half of 0.3 is this. So it should give you half of that. Which is 6 lor. Correct not? Right? Okay, so this is the same thing. I put the same amount of force on the end and in the middle, the same force. But do you see that my overall moment of force is higher if I go further? Right? My overall force is lesser. We don't call overall force, okay, moment of force. Understand not? Now, next one. Now, mathematicians, listen. I have 5 kg. Okay, I have 5 kg or 50 Newton of box over here. And the distance is 3 meter. Okay, let's make it easy. 2 meter. Okay. I have another box of 5 kg. Where should I place this box on the seesaw so that the whole thing is balanced? Easy? Correct or not? I should place 2 meter away, then balance each other lor. 对吗? Correct? Can I? Easy. All of you know. Let me change it up to 10 kg. 2 times heavier. All right, 2 times heavier. Now tell me, where should I place my 10 kg on the seesaw so that it balances the whole seesaw? You say what, huh? Put on the middle, 10 kg. You will be guaranteed that the middle down here, 10 kg, 5 kg will go down. Fail. Experiment fail.
1 meter.
How you measure? How? Why? How do you measure come out in 1 meter, eh?
Smart.
Huh? Because double ma, correct not? So you should put 1 meter. Can see that not? Heavier 1 meter. Now, do you see a pattern here? The next formula, you have figured out the next formula without me telling you really. How do I come up with this is equals to this? Can you come up with the formula? That means what? This one times this one. 5 times 2 equals to 10 times 1. Exactly how you use the next formula. Next formula is, I ask you to find this kg. Is this times this must be equals to this times this. You can find this. As you find this, is this times this equals to this times this. So I cover whichever you are able to find. Yeah, the other side. Understand that? Yeah? Okay, so let's look over here. Okay, the lever. So load times load to fulcrum. Again, load times load to fulcrum is always equals to effort times effort to fulcrum, distance of effort to fulcrum. So let's look at an example over here. Question asks you, calculate the weight of X. How heavy is X? So X times 1 equal sign this times this. You can find X. Right? In any mathematical equation, you can find 3, you can find plus. Alright, huh? Okay, go. Do you guys learn simultaneous equation? What? Form 1, got that. Okay. Which one is x plus y equals to 3, 2x plus 2y equals 4, and then you find x and y to eliminate and kick the x and y part. Okay. Okay, now, anyway, try this one, calculate the weight of x. First of all, put the number into the formula first. Say, teacher, how do I know which is load, which is effort? Doesn't matter in this case. Okay, this one can be load, this one can be effort. So just put a simple one. X times 1 meter is equivalent to 15 Newton times 25.5 meter. No calculator, you got no answer. So one of you better sacrifice your calculator. Or the smart one, say she's smart, please calculate for us. Answer? Later, batteries or phone. Hurry, make use of the calculator. The phone is like, huh, I got more use than just Instagram and Facebook. By the way, do you guys have Facebook?
Yeah.
Huh? I thought young people don't have it.
Yeah.
All my parents. Right? Old soul, old soul. Young but old soul. What you need? M and M.
M square.
No.
M cube.
Wait, M is here. What is this? Just N only. You cannot see. Okay, show you. You really cannot see, huh? MM. Wow. 37.5 Newton. Cartoon lah, you lah.
Yeah, because too smart already.
Too smart already.
Too smart already.
Next. I'm going to show two children sitting on a seesaw. What must Ali's distance from the fulcrum be for the seesaw to be balanced? Because you know who is Ali by now, hopefully. So how far should Ali sit if Ali is 600 Newton? So that the seesaw will be balanced and doesn't go. So 600 times D equals to 450 times 1.5 meter. So D is just jumping. Weird. What's the final answer? Hello? Hola. What's my final answer? Don't have. 1.125 meter. So if Ali wants the whole thing to be balanced, he should be sitting 1.125 meters away. Understand? Now, next time when you go and play seesaw, you can up your game already when you play seesaw in the future. When you go seesaw, instead of seeing seesaw, like small kid like that, now you can as a more mature person, you see the seesaw. Titi, Mei Mei, come, let's do it differently. Let's play seesaw. I'm going to sit this point of the seesaw. Let's see where do you sit so that our seesaw is balanced. All this time you just boing, boing, boing. Ma. So now you play, how do we balance this? Yeah. Huh? Because we torture you. Okay, so just have to see. Just have, hey, you see here, you see here. Okay, I want to study now. Let me see. Where should I stand for us to be balanced? Let me see. The wall, the kids all right away. Okay. They asked me to study science and mathematics. I give it to have fun. Okay, now let's go to the next one. Pressure. Now, what else can we do with force, a push? See over here. Okay, my handphone. Let's say I press a force of 5 Newton, 10 Newton, make it simple. 10 Newton, push in, right? Nothing happened to my hand. But that same hand, I push into the same force. You can try it on your own hand. Same force of 10 Newton. Pain. Why? Both also I press 10 what? Why pain? The first one is the second. Because this one very thin. Which part is thin? The tip, exactly. This is called the surface area of contact. So now, force can be the same, but when I change the surface area, I create a different thing called a pressure. Understand? Yeah? So that is why knife, for it to be sharp, the surface area has to be thin. Understand? The big tractor, the big cranes, how's the wheels? Big, right? Large and big, because it's heavy. It's heavy. I cannot use bicycle wheel. Then all the weight would destroy the bicycle wheel. Correct? So I have to increase the width of the surface area so that the force is spread evenly so that it will not destroy the wheels. Okay, so pressure. So we start to extend things using force. From force, I can add more things. When you go higher level, you can extend more formula from there. So force per unit area is the meaning of pressure. Divide by area. Okay, again, the area is the area touched by the surface. So the SI unit for pressure, you can put, okay, N divide M square is, what is my final unit? How will you write it? Not NM square. NM negative 2.
Oh, no slash.
Oh, okay. You put slash also can, like that. Can also. Okay. Or you can put it as this. Then you don't put slash, you don't put slash, then you change it to negative. Okay. Or if you don't put this one, you can change it to PA. What do you think PA is? Anyone else? 一个 pa 是 pa means what? What does pa represent? Pascal. Okay, Pascal, name after the scientist. Now, you guys got to learn Pascal triangle. Mathematics. What? Last year. Okay. Now, a force of 200 Newton acting on an area of 0.02 meters square. Find the pressure in units of PA. So find pressure 嘛，对吗？ So my title of course should be pressure 咯。So what's my pressure? What's my force? Look at formula. Pressure is what? Force divided by surface area. So force divided by surface area. What the lines need to disappear this recent. How much? Calculator. Hey, don't waste time, faster, quick. $10,000. What you need? PA or Newton meter magnitude. Okay. A car has a weight of 1,500 Newton. It's actually very light. 1,500 Newton is how many kg? Anyone knows? How many kg is 1,500 Newton? If I convert to kg, 150 divided by 10 only. 150. Imagine that's maybe it's a model car only. Huh? The area of contact of each tire is 0.3 meters square. Li Chi, 0.3 meters square is one tire touching or four tires touching? Read question one more time. One. Each tire is 0.3 meters square. Right? Calculate the total pressure exerted. Exerted is a new word I want to teach you. Exert means you exert a pressure. We don't say we push a pressure. We don't say we create a pressure. We say we exert a pressure. Understand? So, how to calculate the total pressure? What's the formula for pressure again? Force, right? What's my force pushing down? What's my total force pushing down on the ground? 1,500 Newton. Now, 1,500 Newton is pushing on how much of area? How much wheels? 4 wheels, correct? So 4 wheels of 0.3. Agree? Since I got 4 wheels, 0.3 meter square times 4 wheels. What's my answer? 1.2 correct? Final answer? Mathematician, jump. 1250. Everyone thank Isaac already. Doing all the work. How much is pressure exerted by each tire? So 1250 is the total pressing on 4 tires. So one tire is how much? One tire will carry how much? 0.3 is the 1250 is 4 tires touching. So one tire is 1250 divided by 4 lor. 明白吗? Yeah. So pressure by each tire, pressure exerted by each or on each tire, by each tire is 1250 divided by 4. Final answer? PA of Newton meter magnitude. Hey, what's with this M? Is it my app or is it the pen? Can. Okay, take a short break. Come back. 3 minutes. Short break. Don't eat here, don't eat in class. You want to eat, you eat over the sink or in the kitchen because there's a lot of crumbs. You created a marble run. Speaking of that, any of you know what a marble run is? Yeah. This one. No, it's designing this one, right? So you guys are free. Yes, come earlier. We have a RAM cardboard over there. Our students have done some already. So for a start, we did a simple RAM. But I mean, I only started like what, yesterday, 2 days ago. And then as you progress more, you all can start adding more things. Start adding, of course, we start off with simple one lane, one lane, one lane. But slowly then you'll start to design this cardboard, design curl, curve, curve, curve. Then maybe you design yours, your friend design theirs, and then both of you combine so that the gully from theirs roll to yours. So we're going to add more and more features. So a lot of science at work over here, things like mortality, friction, things like slowing down, things like speed, things like angle of inclination, right? A lot of things to modify, and then slowly we will then only slowly we will upgrade to more and more Chang'e. So at least there's some hands-on work, hands-on things for you to play around, right? Wasn't this the same thing like just now? Oh, this was the same thing like just now. Okay. Oh, so here's what it is. Right? Anyway, let's go back to class. Yay, class. Okay, finish this last part. Can? So let's look over here. Look at metal block P and metal block Q, right? If I use the scissor cut both of them, right? The metal block will fall on the plasticine, 对吗? You know what's the plasticine, right? The Play-Doh one, plasticine. Now, when both of them drop, what they will do to the plasticine? They will kill the plasticine some more. They will make a dent, make a hole, correct or not? Yeah, you can hole ma. So the question is this: P or Q, who will make a deeper hole? P or Q? So P will make a deeper hole inside. So when it drops, it will create a bigger hole. Now, we don't say bigger hole. We say a deeper dent. Understand? So, what we call your responding variable over here, now so technical already, use the word the depth of the dent. Depth means how deep is the dent. Understand? So if you can see over here, P, the dent is 3 meters in, Q is 1. Now let me ask you, why do you think P dropped the time, boom, cucuk deeper inside? Why? What's the difference between P and Q? What can you see? One is standing, one is lying down, right? So what is the thing that's the technical term? They are what? The surface area, correct or not? Yeah, the surface area is smaller, the surface area is bigger. So what can I say? If surface area is smaller, the what is higher to create a deeper depth? They create a stronger pressure. Okay, look at this formula over here, just in case you don't know mathematics, right? Whenever a surface area goes up, bigger surface area, this one will always go down. In mathematics, these two will always fight each other. Right? So if this one go up, pressure will be lower. This one, smaller surface area, higher pressure. Understand? Okay? So let's look over here. Okay, larger the surface area, the lower the pressure exerted. Itu sahaja. So this is all about changing the surface area. Let's look at an example over here. Have you guys been ice skating before? Yes. Yeah, I always been to ice skating area. I always want to try. But I end up enjoying more when I see people down there like fall down. Okay, now I don't know because I know I will confirm fall down. Okay, now why is it made up of plate? Why is it made up of plate? So tell me about the surface area, big or small, the surface area of the blades. Small surface area. When the blade has a smaller surface area, I create a greater pressure on the ice or lower pressure on the ice? Higher pressure on the ice. Now, why do you need a high pressure on the ice for? Go faster, but you can grip onto the ice as well. Cut through the ice, grip tightly onto the ice. Yeah? So, highlight, thin metal blade, higher pressure, exert higher pressure. Next thing goes to knife. Knife surface area is smaller, correct or not? Yeah, so low surface area, high pressure. There you go, simple. Football boots. Any of you want football boots before? Any of you got football boots? Isaac got it? Don't have. So, what football boots are there?
No, don't fall down.
So that you don't fall down your ski. Yeah, because if you wear flat, right, and then the grass can be wet, slippery, right? Then you'll be like, yeah, like ice skating like that, right? So what happened is they create what you call all these structures. These structures are called pronouns studs. Okay, they are studs on the shoe. Tell me the surface area, big or small?
Big, small.
Small surface area. Small surface area will create a higher pressure on the ground, right? So you can grip. Okay, exerts a higher pressure so that you get a better grip. Easier for footballer. Now, to make this thing is a bit tricky as well. It cannot be too thin as well. If too thin, then the whole shoe sink inside already. Correct or not? Then the floor run like, I have to keep digging out soil. Right? So it has to find the right balance between the force and also the surface area. Next, this will be the opposite. Heavy giant elephant up here. So heavy, but I need to balance the force. So that's why you increase the surface area of the wheels so that the force is spread and shared by all area of the wheels. Understand, ma? Okay? So tires are big and wide, produce a Larger surface area means you have a lower pressure exerted. Boleh? Itu saja. Latihan? No. Your class punya latihan. Morning, yeah, it's yours. Okay, now let's look at question number 4. Hey, this one we haven't do yet. Can we go to page 3?
Sure.
Huh? I don't know. She said she couldn't come today because she got some project. We do what project? PBL. Property learning. Yeah. So what is she supposed to do on the project? Huh? Sell food.
Sell food, sell drinks, and then they're presenting blah 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 blah.
4 ringgit, one slice of pizza.
4 ringgit ah?
It doesn't say it's a
这样不贵啊？
4 ringgit for slice of pizza. So you all buy it.
No,
Maybe the pizza is nice.
maybe not.
They buy Domino's and then they sell Domino's to you all. They buy at low price, sell at high price. No. They make their own pizza, is it?
They say some.
Discount. 4 ringgit for a slice, for the whole pizza, then yeah, fun. Okay, ready? Actually, right, 4 ringgit, right? For a slice of pizza, maybe I just convert the pizza into a round circular shape, right? 4 ringgit, right? Some students probably will end up buying. Probably the area is like the same size. 4 ringgit or one whole pizza. Alright, that's like pretty much the same size. If they need to do a circular shape, right? Students will not see it as one slice. They see it as a whole piece. Okay. Now let's look over here at page 3. W is what? Action, force, reaction. Okay, next up, what's the answer? Moves a stationary object. B, speed. C, direction. Stopper. Shaper and sizer. Okay, can both. Okay, shape and size. In this case, it's shape. Okay. Next up. Here, number 4. So can you identify the first, second, and third class lever? You like eat ice cream regularly. Want to eat ice cream regularly. Please don't throw the ice cream sticks. Please keep it and wash it and donate. But of course, make sure you finish your ice cream. Don't bite your ice cream stick. And then the teacher, donate to me. I don't want to buy. Okay, once you finish your ice cream stick, please remember me. Donate to me. We can. I'm such an older age. So if you never eat this,
It's very old.
I mean, I have to start taking care of my health already, right? I cannot eat so much sugar, you know. I have to cut down on my one meat share and all. Nearing already, I have to cut down on my meat share, I have to cut down on all my boba, everything. Huh? I don't look like it, man. Thank you so much. I give you extra biscuit later.
My mother also. Yes.
大学生 you are touching 40 already. Okay, first one, some more class. Third class lever, E is in the middle, F is in the middle, will be first class lever, and load is in the middle, will be second class lever. Correct? So third, next one you have to identify, this is where, first easiest is identify where is the fulcrum. Fulcrum for here is in the end here. So the load is in the middle. Alright. Load pula. Effort is in the middle. So this gives you your third class lever. This one, load is in the middle. Fulcrum is here. Effort is here. L in the middle. Here. This one, first class. Why is that so? This is your effort. Where is my load? Where's the object I want to move?
There.
The nail. Where's the point that does not move? Here. You see that? So that's why you push there, it has to stop and lift the other side out. It's a seesaw motion. Seesaw motion is always first class. Yeah? So, first class lever. Easy? Easy peasy. Number 5. I see anyone can read the formula properly here. You now, number 5, formula given to you. Read the formula carefully. Okay. 7.5. Let's see the rest. What the question ask you? What the question ask you? What is the load? And then you ask back the question, what is the load? So you have to find load lah. Again, first of all, what they ask you to find? The weight of the load. Right? They ask you to find this one, correct? Do you know? Of course you don't know, right? So load times. What is my distance of load? You use load. What's my distance? 10, correct? Huh? Equals to, where's my effort? 10 Newton. Given here already. 10 Newton. 30 cm. Exactly. Just now I didn't teach you, I teach you the seesaw, I teach you, that's because the fulcrum is in the middle. Now fulcrum is at the side, focus back to the fulcrum. Okay, so load is 10 times 30 divided by 40 is, what's the answer again? 7.5 Newton. Boleh? Okay? Okay. Next up. This one homework. This one homework. If you finish it, then okay lah. Sudah siap? Sudah siap? These three. This one, last one. Sudah siap dan baguslah. Page until here. Until this football boots. Are your lessons so easy? Next week with the air pressure and water pressure. Can? Now we can go up play for one. Can? Done? All right. So we stop here.